Okay, in this next procedure, procedure 4, we want to carry out calibration of the transfer pipette. Do you remember the first calibration we did was to calibrate for volumetric flask? So this time around is for us to calibrate for this, because this is also a measuring apparatus. Apart from being a measuring apparatus, we also use it to transfer liquids from one container to the other. So this is actually a pipette, a 5 ml pipette precisely. We have pipette of different sizes, but I learned that in the lab you guys will be making use of the 10 ml pipette. So whichever procedure we use here, we just understand the steps, it will be very easy for you to replicate it with a larger pipette. Okay, remember in the cases of volumetric flask, okay, in the case of volumetric flask, we had to weigh the flask when it was empty. We can't weigh the pipette when it is empty because pipette cannot hold back solution, right? The both ends are open. Okay, so what we are going to do now, for us to be able to calibrate pipettes, we'll now introduce what we call the Lemire flask. This is a Lemire flask. Now, what is the sole aim of this flask? Listen, we are going to weigh this flask when it is empty so that we can know the mass of this flask when it is empty. Okay, when we are done weighing the mass of the flask when it is empty, when we are done weighing the mass of the flask when it is empty, whichever solution, whichever content we transfer into this, we can weigh it again and of course subtract it from the mass of this when it was empty to now get the mass of what is inside here. Okay, briefly I repeat, we are going to weigh the mass of this when it is empty. So let's try this out. Okay, so when this mass is empty, I'm getting 38 grams. So I'll come to this table number 4. All right, 38 grams. Remember, in the lab, they might give you guys something bigger than this. This is a 100 ml Lemire flask. In the lab, they might give you guys 250 ml. Okay, so the most important stuff is that please do not just transcopy this data here. Make sure you carry out your own analysis or your own experiment. Now, this video is just to help us understand this step better. We have weighed this stuff when it is empty and we are getting 38 grams. What are we going to do, class? Let me read out the procedure 4. It said calibration of transfer pipettes. Colon. Use the transfer pipette to deliver 5 successive aliquots of each of the 2 liquids into a small Lemire flask. They said use transfer pipette, this is a transfer pipette, to deliver 5 successive aliquots of each of the 2 liquids into a small Lemire flask, which is weighed before and after each transfer. From the differences in mass and the liquid density, the volume delivered by the pipette is calculated. We have 2 liquids, liquid A and B, so we are going to carry out this process twice, but we don't really have enough time. Just like I told my students, if you just do this once, of course, you could just use the knowledge from the one and get the other one. So what we are simply going to do, they asked us to fill in this and transfer and deliver it 5. The main purpose of delivering this guy 5 times is basically just to get the average. If you could recall, in titration we do first titrat, second titrat, and third titrat. At the end of the day, the volume of the acid used would be addition of the first plus that of the second and the third and divided by 3. So in this case now, you realize that the value you're going to get as the average volume will somehow be very close to each of the individual answers. So they are asking us to carry out this in 5 consecutive times, one after the other. But we don't have enough time. We may not really have that enough time in the lab, so I'll just expose us to a kind of a shorter method of doing this, which is simply you weigh this just once. Just how many? Once. Just once. Just weigh this guy once. Okay? Once you weigh this guy once, you are cool. If you weigh this guy once, it's just like saying if I do this in 5 times, let's say if I use water, the density of water is 1 gram per mil. That simply means for every 1 gram of water, for every 1 mil of water, if you measure the mass of that water, it will be 1 gram for water. If you measure 5 mil of water, the mass will be 5 grams. If you measure 10 mil of water, the mass will be 10 grams, because density of water is 1 gram per mil, or 1 gram per centimeter cube, meaning that for every 1 mil of water, the mass is 1 grams. Okay, so this flask, this pipette is 5 mil. I'm actually trying to expose us to the shorter method now. This guy is 5 mil. Okay, for the fact that this guy is 5 mil, if you take water up to the 5 mil here and transfer it into your pipette, and transfer it into this flask, and you weigh, listen, the flask when it was empty was 38. Let's do this first step first, so that, let me use alright, so we have this. I've gotten 5 mil. I'll transfer this guy inside. Now if you weigh this, we are getting 43 grams. Right? But in this question now, they said what they said is mass of a linear flask plus aliquot of liquid A average. Class, the average is definitely going to be average of 5 plus 5 plus 5. Like each of this takes 5 mil. In the lab they might give it 10 mil. In the lab they might tell you not to do it up to 5 times. They might tell you to do it 3 times. But here we are just following we are following what is inside the manual. They said you should do this in 5 times. So I'm supposed to take another of this, second time, take another of this, third time, take another of this, fourth time, take another of this, 5 times. Okay, that means if one of these pipettes delivers 5 mil and density of water is 1 gram per mil, that means that 5 mil delivered by this will have 5 grams. 5 grams in 5 places will be 25. Now that 25 was gotten out of, because we did that stuff 5 times. If you divide 25 by 5, you're going to get 5. I repeat, we're going to deliver this 5 times into this, and this guy is 5 mil. So from density of water, 1 grams is equals to 1 mil. Okay, so if you deliver 5 mil of water, the mass will be 5 grams. And we are asked to deliver this 5 good times, 5 successive times. So when I do this the 5 times, the total mass of water I'll be having here will be 25 grams. But remember that 25 grams is gotten by using these 5 good times. For me to now know the average that one delivered, alright, I will now say 25 divided by 5, which is 5. Alright, now what I will be recording here is going to be 5 plus 38. Assuming I made use of 10 mil pipettes, if I had made use of 10 mil pipettes, what I'll be recording here is 10 plus 38. That is going to be 48. This 38, because our elemental flask when it was empty was 38. Because when this guy was empty, it was 38. When I now transferred 5 mil of this, 5 mil is the same thing as 5 grams because it's water. This 5 plus 38 is 43. Right? So what I'm going to record is going to be 43. I'm not going to record the mass of everything the 5 times I did this. No, because it said average. The average only affects the liquid. You know, some persons will start dividing the average with the mass of the flask. Class, you only made use of the flask once. So why would you divide this flask 5 good times when you just made use of this flask just once? What is inside this liquid is actually what you're going to do, divide by 5, because you were asked to do it 5 good times. Alright, but like I said, to save time, you don't really need to do it 5 times. Just one of it is okay. Do it once, measure it, record your answer here. And that is exactly what I'm going to do here. So this is 43 grams. You do that with ethanol. You do that with ethanol as well. I've already done this with ethanol. Ethanol actually gave us 42 grams. How will I do this? Empty this guy, take ethanol once and put it and weigh it. You could decide to do it 5 times if you want to, or if you do it 5 times, make sure what you're going to record is going to be the average of what is inside this plus the mass of this flask when it is empty. If I had done this 5 times, that means I would have gotten 25 grams of this liquid inside. 25 grams plus 38 will be giving us 63. You are not to divide 63 by 5, because if you divide 63 by 5, you're also including the mass of the linear flask. Okay? So we have this to be 43. You do the same thing for ethanol and you get 42. Okay? Now, how do I get the volume of pipette? Just like we did for volume of flask. The same formula we used for when we did volume of flask. To solve for the volume of pipette will now be mass filled with aliquot of A minus empty, mass empty of a linear flask. So for me to get the volume delivered by this, I'll use density equals to mass over volume. Okay? Once I use density equals to mass over volume, let me solve this here. We have from density equals to mass, volume of pipette equals to mass all over density. Now the mass of water here is going to be 43 grams minus 38 grams. Remember, we want to know the volume delivered by one pipette. That was why they said average. If you actually say, now look up, this will deliver this 5 times. If we use water, 1 gram of water, from the density of water, 1 gram per mil is the density of water. That means if 5 mil of water is inside here, the grams of that water will also be 5 grams. If 10 mil of water is here, the mass will be 10 grams. So since this pipette is 5 mil and it's going to deliver 5 mil, it means that the volume delivered by this pipette will be equivalent to 5 grams. And they say you should do this 5 times. 5 into 5 places is 25. Class, 25 plus 38. Because that 25 will be inside this LMAR flask. And if you weigh this LMAR flask with the 25 grams of water inside here, you're going to get 63. This average here, if you divide that 63 by 5, the answer you get will be wrong. Do you understand? Because we made use of this guy just once. The flask is just 1. So why would you want to divide the flask 5 times? Huh? What you're going to divide 5 times is going to be the liquid content of this. So we got 25. 25 divided by 5 is 5. 5 plus 38 is 43. That is what we have here. So for you to now get the pipette, the volume of this pipette, from this formula, density equals to mass over volume. Volume of pipette equals to mass over density. Now the mass of this guy becomes 43 grams minus 38 all over 1 gram per mil. Now this is 5 mil. And this corresponds to the volume of this pipette. Okay? This corresponds to the volume of this pipette. Straight and forward, no stress. Okay,